This video will focus on how to calculate an answer when you're given grams and you're going to moles. So in this problem, I see I'm given 8.15 grams of aluminum and asked how many moles of copper can be produced. So within my chemical reaction up top, I am given some amount of aluminum and asked how much copper can come out. So it's a gram to mole problem. Step one, I'm going to always write down where I'm beginning, which is the amount of grams of aluminum. I'm going to multiply, set up my first conversion, and then grams of aluminum is going to come to the bottom. And that's because wherever I'm starting, that dimension comes to the bottom. Now with stoichiometry problems, when I look at the label where I'm starting, if the label I'm starting in is not mole, then my first step is to use mole. Okay? So my first step for this problem is going to be to use molar mass to get me to the mole so that I can do stoichiometry. Molar mass is always some number of grams per 1 mole, and that number of grams can be found on your periodic table. Now I'm not done with the problem yet because I haven't actually done the stoichiometry, so I'm going to write another conversion factor. The grams of aluminum have canceled because the top and the bottom cancel. So now, after my first conversion, I'm in moles of aluminum. That was my goal. I'm always trying to get to moles of aluminum, I'm always trying to get to moles of my substance so that I can use my mole ratio, which is the definition of what stoich is, to get 2 moles of the thing I'm solving for. In this case, it's copper. Those numbers then that go along with that conversion factor are just the coefficients. So 6 for copper and 2 for aluminum, because that is what the coefficients are for those substances. Now, once I'm in moles of copper, this problem actually stops right there. I don't have to do that last molar mass step. And I don't have to do that step because the problem asked me about moles of copper. And that is what I've converted to, right? Moles of aluminum have gone away. I will get moles of copper out when I calculate this. So this is just a 2-step problem. Putting this into my calculator, I'd put in 8.15 divided by 26.982 times 6 divided by 2 to get me to my answer. My calculator gives me this answer. And because my initial number was just 3 significant figures, I would round my final answer just to 3, and then also the label. So 0.906 moles of copper is how many can be produced from 8.15 grams of aluminum. So in general, problems that start with gram that are ending in mole will always go the same way. I'm going to multiply first by my molar mass, knowing that my molar mass number will come from the periodic table and the mole is always 1. Then my next step is going to be to take this substance A I've been working in and change it to substance B through the use of the mole ratio, right? The mole ratio, which is what stoichiometry actually is. This is the key. The numbers for the relationship will come from the coefficients. And then for a problem that needs to stop in mole, you're done. It doesn't go any farther than that. So that's just a 2-step problem in order to solve for how many moles of some substance comes out from grams of a different substance.